You know, it usually happens when you least expect it. You're reading this report generated by an AI, and it sounds just incredibly confident.
Oh, yeah. The grammar is flawless.
Exactly. The logic seems perfectly structured. The citations are all neatly formatted there at the bottom. And you just accept it as reality.
Because it mimics the exact structure of truth.
Mm-hmm.
I mean, human beings are fundamentally wired to trust things that look authoritative and well-packaged.
But then you actually click one of those citations, or maybe you double-check a specific statistic against reality, and you realize it doesn't exist.
Yep. It's completely made up.
The AI completely hallucinated it. It just fabricated a reality out of thin air, packaged it up in a very convincing suit, and handed it to you. And that initial comfort you had just evaporates.
It's a terrifying realization.
It really is. You are suddenly looking at a system that is undeniably powerful, but entirely disconnected from verifiable truth.
And that exact vulnerability, trusting the data underneath the AI, that's the massive trust deficit our sources are pointing to today.
Right.
As artificial intelligence starts routing our global logistics or running our climate models and executing trades in our financial systems, the stakes of a hallucination go from a funny mistake in a term paper to a catastrophic real-world failure.
Yeah, you don't want an AI hallucinating a cargo ship's coordinates.
Exactly.
Yeah.
So the question becomes, how do we know the data the AI is using is real? How do we prove a physical event actually happened before an algorithm acts on it?
Okay, let's unpack this. Because the sources we've pulled for this deep dive, which include official documentation, some market forecasts from mid-2026, and crypto news analysis, they focus on a fascinating solution to this exact crisis.
They do.
We are looking at the XYO Network, and specifically a massive architectural leap they made on September 16th, 2025.
Right, the layer 1 transition.
Yeah, they transitioned from being an ERC20 token, which means they were essentially renting space on the Ethereum network, to launching their very own sovereign layer 1 blockchain. And they built this new architecture from the ground up to do one thing.
To anchor physical reality securely.
Exactly. So for everyone listening, our mission today is to figure out exactly how this architecture actually functions under the hood.
Well, to understand the engineering behind that move, we really first have to look at the structural limits of legacy blockchains. Developers refer to this as the storage problem. Mm-hmm. Or state bloat.
State bloat.
Yeah. When you look at the chains most people know, their architecture is fundamentally cumulative. Like, Bitcoin's ledger is currently sitting at around 650 gigabytes.
Wow.
And Ethereum's archive nodes are over 1.2 terabytes and climbing every single day.
Because every single transaction, every smart contract execution from the literal dawn of the network is just piled on top of the last one.
Exactly.
Yeah.
And that creates a massive bottleneck.
Yeah.
To participate fully in validating those networks, you increasingly have to rely on giant centralized cloud servers just to hold all that historical data.
You definitely can't run a terabyte heavy node on a smartphone.
No, or a standard IoT device.
Yeah.
Now, if your goal is to verify millions of high-frequency sensor readings, temperature gauges, drone coordinates, traffic cameras, for an AI agent in real time.
You can't be dragging around a terabyte of historical baggage.
Oh, right. The system would just choke.
It's like, think of a bustling library front desk. If the librarians tried to stack every single newspaper ever printed on the counter to use as a reference, which is essentially what Ethereum does, eventually the desk just completely collapses under the weight.
It becomes totally unusable.
Right. So XYO approaches this entirely differently with something they call the look-back window. Instead of keeping every newspaper, they only keep this week's papers right there on the desk.
That's a great way to look at it.
The active data set on XYO Layer 1 is bounded. It never grows past a fixed, predetermined size. The nodes operating the network are only required to store the most recent n number of blocks.
And that bounded window is what keeps the blockchain incredibly fast and lightweight. I mean, the chain runs at the exact same speed on day 1 as it does on day 10,000.
Because there's no buildup.
Exactly. There is no historical lag to slow down processing, which is an absolute prerequisite when you are building infrastructure for robotics and AI.
I'm tracking with the speed benefit, but I have a question here. What if an AI actually needs an old newspaper?
Yeah, good question.
Say an insurance algorithm needs to verify a piece of flood data from a sensor that was recorded a year ago. If the front desk threw that paper out to save space, isn't the data lost?
Well, it isn't thrown out, it's just archived separately. The genius here is how the network retrieves it. Older data remains fully accessible on demand through a cryptographic mechanism called a bearer proof.
A bearer proof?
Yeah. Think of a bearer proof like a coat check ticket. The blockchain doesn't need to keep your heavy coat at the front desk. It just needs to look at your tiny cryptographic ticket to mathematically verify that the coat in the back room belongs to you.
And that it hasn't been tampered with.
Right. The person or the device requesting the data brings the proof with them.
Oh, wow. They bring their own receipt to the transaction. That takes the burden completely off the main network.
Furthermore, to find that specific data in the archives without slowing the whole system down, XYO uses something called a step hash.
How does that work?
Well, instead of forcing the system to crawl backward linearly, block by block looking for that one old record, a step hash creates cryptographic shortcuts.
So it can jump around.
Exactly. It allows the network to make giant leaps, skipping over huge chunks of irrelevant history to find exactly what it needs almost instantly.
That solves the blockchain bloat problem beautifully. But wait, if the blockchain itself is being kept intentionally light-like, if we're only dealing with these tiny code check tickets, where is all the actual physical data going?
Ah, right.
Because we are talking about petabytes of real-world information, video feeds, GPS coordinates, temperature telemetry. That stuff is incredibly heavy. It has to live somewhere.
It does. And this reveals the core design philosophy of XYO's architecture. It's off-chain data, on-chain proof.
Off-chain data, on-chain proof.
Yes. The heavy payload, the petabytes of actual sensor readings, does not live on the blockchain. It is routed into decentralized storage systems called data lakes.
Data lakes, okay.
These are cryptographically secured off-chain environments designed specifically to hold massive files cheaply and efficiently.
And the only thing that actually touches the XYO Layer 1 blockchain is the tiny proof that the data was deposited and hasn't been altered?
Precisely. And to optimize that even further, the network utilizes ZK rollups or zero-knowledge rollups.
I've heard of those. They bundle things, right?
Yes. Rather than sending 1,000 individual receipts to the blockchain one by one, a ZK rollup uses some very advanced cryptography to bundle those 1,000 transactions together.
Making it super efficient.
Right. It creates a single, tiny proof that mathematically guarantees all 1,000 underlying transactions are valid without the blockchain actually having to process or read any of the individual data points.
That's wild. You're basically taking 1,000 heavy suitcases, putting them through a magic cryptographic zip file compressor, and handing the blockchain a single piece of paper that says, I promise the math checks out on all of these.
That's a perfect analogy.
And the blockchain can instantly verify that statement is true.
That combination of data lakes for storage and ZK rollups for validation is what allows the network to handle the sheer volume of a decentralized physical infrastructure network, or DePIN.
Right, because DePINs generate a ton of data.
Massive amounts. We are talking about a pipeline driven by over 10 million active nodes globally. Many of them are just everyday people using the Koiai app on their smartphones.
Let's map out how that data actually travels from a smartphone to the blockchain, because our sources highlight 4 distinct roles in this ecosystem.
Okay, let's break them down.
If we use a real-world scenario, let's say a delivery drone is dropping off a medical package at a hospital. The first role is the sentinel. Sentinels are the actual physical sensors. In this case, it's the GPS unit on the drone itself, or maybe a smartphone in the hospital receiving dock actually collecting the raw telemetry out in the physical world.
And then the sentinel broadcasts that data to the second role, which is the bridge.
Bridges, what do they do?
Bridges act as the relays. They don't store the data long term. They basically just listen for the sentinel signal, check that the formatting and basic cryptographic signatures are valid, and then securely transport that data package to the broader network.
Which brings us to the third role, the archivists.
Yeah, the storage layer.
These are the nodes managing those data lakes we talked about. They receive the data from the bridges, lock it into deep storage, and index it so it can be easily found later.
Finally, you have the diviners. These are the validator nodes. They're the actual brains answering questions.
So they fetch the data.
Right. When an enterprise system or an AI agent submits a query asking, say, did this specific drone deliver the medical package to these exact coordinates at 2 p.m., the diviners fetch the index data from the archivists, evaluate the cryptographic proofs, and serve up a verified, definitive answer.
Hold on. I see a massive loophole here.
Oh, let's hear it.
We've established that the heavy data sits off-chain in a data lake, and only the ZK rollup receipt goes on-chain. But if I'm a bad actor, couldn't I just spoof my drone's GPS to say I delivered the package when I really kept it?
the garbage in, garbage out problem.
Exactly. I send that fake data to the archivist, it gets zipped up in a rollup, and boom, the blockchain perfectly validates a complete lie. We're just moving the AI hallucination problem from the blockchain to the physical sensor.
Well, that is the single greatest vulnerability in IoT networks. And it is exactly what XYO's bound witness technology is engineered to solve.
Bound witness.
If we connect this to the bigger picture, a bound witness fundamentally changes how data is recorded. It is not just one device blindly shouting, "I am here." It requires a cryptographic handshake.
A handshake between who?
Between two independent nodes. They must mathematically co-sign an interaction together at the exact same moment in the same physical space.
So my hospital receiving Doc's smartphone and the delivery drone both have to cryptographically sign a receipt saying we see each other right now and our coordinates match.
Precisely. They exchange cryptographic keys that are inextricably linked to that specific time and location.
Oh, that's clever.
Neither device can generate that specific signature alone. And through a process called bound witness elevation, that off-chain dual sign handshake is promoted. The network algorithms evaluate it, verify the dual signatures, and elevate it into a settled, unalterable on-chain proof.
It creates a proof of origin.
It creates an unbreakable chain of custody. If an AI looks at that data later, it isn't just trusting a solitary sensor that might have been spoofed. It is trusting a mathematically verified multi-party consensus that occurred in the physical world.
Because you can't fake the other party's signature.
Right. You cannot alter or spoof that after the fact without completely breaking the cryptography.
Okay, here's where it gets really interesting. You have millions of these bound witness handshakes happening constantly, right?
All over the world, yeah.
Drones, smartphones, traffic cameras, all generating these verified interactions. But how does the network actually agree on which blocks of this data get permanently added to the ledger? Someone has to play referee.
They do.
And the sources say XYO doesn't use the standard consensus models we see in the rest of crypto. They built their own protocol called Proof of Perfect.
Proof of Perfect, or POP, represents a radical departure from traditional consensus. To see why, we have to look at how legacy chains agree on truth. Take Proof of Work, which secures Bitcoin.
That's a massive energy drain, right?
Yeah, it's essentially a brute force competition. The network picks the hardest worker. The node that burns the most electricity and computing power solving arbitrary math puzzles wins the right to add the next block.
It's an arm wrestling match. The biggest server farm always wins.
Exactly. Then you have Proof of Stake, which Ethereum uses. That model picks the wealthiest participant. The more capital you lock up, the higher your chances of being chosen to validate the block and earn the reward.
So it's basically a plutocracy.
Right. Proof of Perfect discards both the brute force model and the wealth model. Instead, it introduces a subjective scoring algorithm that picks the best block based on a rigorous, multifaceted quality score.
So if Proof of Work is an arm wrestling match and Proof of Stake is a plutocracy where the rich just rule the network, Proof of Perfect is a strict meritocracy.
A strict meritocracy, yes.
It's a system where only the highest quality work actually wins. But how do you mathematically define quality without a centralized referee? What is the algorithm actually scoring?
Well, the network automatically evaluates blocks against several core metrics. First, it looks at decentralization. Is this block being produced by a diverse set of participants from different geographical areas? Or is power centralizing around one major hub?
Ah, so it wants a diverse map.
Yeah, the algorithm mathematically penalizes centralization. Second, it looks at payload volume. Is this block actually carrying a dense, useful amount of data, or is it mostly empty?
So you can't just spam the network with empty blocks to collect rewards.
Exactly the opposite. And third, it evaluates producer variance. The algorithm actively checks if different nodes are getting a fair chance to win.
So one node can't just dominate the whole chain.
Right. If the same node tries to publish block after block, its quality score degrades mathematically. By scoring these factors, the network achieves anti-fragility. It doesn't just grow larger. The economic incentives force it to become more decentralized, more dense, and more secure as it scales.
And if we tie this back to our core problem, the AI hallucinations, the scoring logic is the silver bullet.
It really is.
The sources point out that the exact same mathematical logic, proof of perfect uses to score a blockchain block, can be applied directly to AI inputs.
And the implications for artificial intelligence are staggering. Imagine an autonomous AI agent tasked with adjusting a city's power grid based on temperature data.
Okay.
It pulls in readings from hundreds of different sensors. Some might be faulty, some might be spoofed. The proof of perfect logic can evaluate all those different inputs, analyze their bound witness history, weight them by their cryptographic quality and origin score, and mathematically filter out the anomalies.
It basically acts as an immune system against hallucinations. The AI isn't just blindly trusting the data, it is filtering reality through a cryptographic meritocracy before it makes a decision.
That is incredibly powerful.
But, zooming out for a second, building a decentralized global machine that is constantly evaluating quality, processing millions of real-world events, and running complex cryptography, that requires an enormous amount of economic fuel.
It takes serious infrastructure.
You need a system that keeps people incentivized to play by the rules. And XYO handles this with a dual token model, utilizing both XYO and XL1.
The transition to a layer 1 blockchain necessitated this split. When XYO was just an ERC20 token on Ethereum, they had to pay Ethereum for gas fees.
They were just renters.
Right. And now that they own the entire infrastructure, they designed a purpose-built economy.
So let's define the roles of these two tokens. First, you have the original XYO token. This is the structural token. It has a fixed maximum supply of about 13.93 billion tokens.
That's right.
It acts as the governance and security layer. Then you have the newly introduced XL1. This is the activity token. It's the gas that actually fuels the network.
And it operates dynamically. Every time a new block is produced, new XL1 is minted to reward the participants. And crucially, every time a transaction happens on the network, the XL1 used to pay for it is permanently burned.
And the bridge between these two tokens is the staking mechanism, right?
Exactly. Participants can lock up their structural XYO tokens in smart contracts to help secure the chain. In return for that commitment, they earn streaming payouts of XL1.
I was looking at the numbers from the sources. It ranges from 50,000 XL1 every 2.3 thousand blocks, all the way to 225 million XL1 every 9.7 million blocks.
Yeah, the underlying economic psychology here is designed to prevent massive whales from hoarding all the power. The tokenomics are structured so that smaller, accessible staking tiers yield a disproportionately fast trickle of XL1, while the massive enterprise-level staking tiers operate on a much slower waterfall schedule.
A listener might be wondering, why introduce a second token at all?
It's a fair question.
If you already have billions of XYO tokens in circulation, why not just use the original token to pay for gas? Doesn't minting XL1 just needlessly complicate the ecosystem?
It might seem complex on the surface, but it's a brilliant mechanism designed entirely to protect the application builders.
How so?
If you use a single token for both open market trading and for paying internal gas fees, your developers are completely at the mercy of market volatility. Imagine building an AI app on the network.
Okay, I've built my app.
Right. Now, if a crypto bull market hits and speculators drive the price of your token up 500% in a week, suddenly it costs you 5 times as much real-world money just to process a basic sensor reading. Your business model is ruined overnight.
Ah, I see. By separating them, XYO isolates the external market volatility from the internal network utility.
Exactly.
XYO can fluctuate on the open exchanges all at once, but the application builders get a predictable, stable ecosystem because they're using XL1, which is dynamically minted and burned based on actual network usage, not hype.
Furthermore, it creates a powerful deflationary loop for the original token. To earn the XL1 gas token, participants have to take XYO off the open market and lock it up in staking contracts.
Which shrinks the supply.
Yes. As the network scales, as more AI developers build applications and need XL1 to run them, the demand for staking increases. More XYO gets locked away, significantly reducing the available supply on open exchanges. It creates a sustainable, self-reinforcing economic engine.
So what does this all mean for you, the listener? We started this deep dive talking about the unsettling feeling of realizing an AI has hallucinated a confident lie.
It's a very real problem.
And we are rapidly transitioning from a world of human oversight to the autonomous agent economy. We're entering an era where AI agents will be making split-second decisions, routing physical goods, diagnosing patients, and executing financial trades entirely on their own.
Without a human double-checking the work.
Right. In that world, trusting the underlying data is not just a nice premium feature, it is the absolute paramount requirement for modern society to function.
And this isn't just theoretical architecture. We are seeing this exact infrastructure deployed in the real world right now to solve these problems.
Yeah, the sources mention some major partnerships.
They highlight a big one between XYO and Theta Edge Cloud. Theta provides decentralized GPU computing power for massive AI workloads. But how do you know the decentralized computer actually ran the AI model correctly and didn't just spit out a cheap, hallucinated result?
That's where XYO comes in.
Exactly. XYO's nodes are independently monitoring that decentralized infrastructure. They are constantly measuring its performance and creating cryptographically backed attestations on the XYO layer 1 to mathematically prove the AI actually did the work it claimed to do.
The sources also point to their work with Resiliox, which is an AI-driven climate risk platform. They are using XYO to provide proof of origin for environmental data.
Because the stakes are huge there.
Oh, absolutely. If you're an underwriter trying to price multi-million-dollar climate insurance policies, you cannot rely on a temperature sensor reading that might have been spoofed by a property owner to lower their rates.
No, you need verifiable physical reality anchored immutably on-chain.
Which points us toward the real frontier of this technology.
Yeah, the sources spend significant time discussing the tokenization of real-world assets. We're moving toward a future where everything from a piece of commercial real estate to the origin of an AI's thought process is being digitized and verified.
It's a complete paradigm shift.
It is. If XYO's proof of location and proof of origin become the ultimate indisputable standards for proving physical reality on a blockchain, it forces us to consider a coming digital divide.
A digital divide? What do you mean by that?
Well, will society reach a point where verified reality, data that has been run through a bound witness handshake, scored by proof of perfect and anchored on a decentralized ledger, is the only truth we are willing to accept?
Oh, wow.
As AI gets better at generating photorealistic deepfakes and flawlessly hallucinated documents, will we get to a future where any physical event, any video clip, or any piece of data that is not cryptographically recorded on a network like XYO is automatically assumed to be a fabrication by default?
Wow. I mean, if you think an AI hallucinating a citation in a report is unsettling today, imagine a world where unverified data is simply discarded as fake by default. It makes building a trust layer not just a technical upgrade, but an absolute societal necessity. Well, thank you so much for joining us on this deep dive into XYO's architecture. Keep questioning the data around you, look for the underlying proof, and we will catch you next time as we keep exploring the edge of what's possible.